Fehling's test, testing for aldehydes and reducing sugars. Attention! Copper sulfate can cause severe irritation of the skin and eyes. It is very toxic to aquatic life and may cause long-term adverse effects in the aquatic environment. Sodium hydroxide can cause severe chemical burns. I don't take any responsibility for damage done to persons or property caused by the recreation of this experiment. For the Fehling's test, two aqueous solutions are prepared, which are called Fehling 1 and 2. Fehling 1 is made of 7 grams of copper sulfate and 100 milliliters of distilled water. Fehling 2 is made of 35 grams of potassium sodium tartrate, 10 grams of sodium hydroxide and 100 milliliters of distilled water. For the test, both solutions are mixed so the copper and the tartrate ions react to form a deep blue complex. The volumetric mixing ratio is 1:1. The copper ion in the complex is easily reduced by many reducing compounds. Commonly, the Fehling's reagent is used to test for reducing sugars. For this, the reactions of glucose and sucrose with the Fehling's reagent are compared. 3 test tubes are used. To the first one, some glucose is added. Sugars are also called saccharides. Glucose is a monosaccharide or single sugar. To the other 2 test tubes, sucrose is added, which is also known as household sugar. This is a disaccharide or double sugar. It is made of glucose and fructose, which are connected by a glycosidic bond. To the third test tube, a small amount of citric acid is also added. Then all samples are dissolved in some distilled water. Next, a beaker is filled with boiling hot water and the test tube containing the sucrose and citric acid is heated for a minimum of 2 to 3 minutes. Then the sample can be removed from the water bath. When it has cooled down, the Fehling's reagent is added. Now all the samples are heated in a beaker with hot water. A positive result is indicated by a precipitate of copper 1 oxide that can exhibit different colors. At the end, all samples can be removed from the water bath. Glucose gives a positive result because it has an aldehyde group in its open chain form. That's why this reaction can also be used to test for aldehydes. The sucrose didn't react because the ring of the glucose cannot open due to the glycosidic bond, so it's not a reducing sugar and the result is negative. The third sample, containing the sucrose and the citric acid, has reacted. This is due to the glycosidic bond because it can be splitted in acidic conditions. This way, all disaccharides can be splitted into the monosaccharides. The monosaccharides then give a positive result. There are also disaccharides that are reducing sugars. An example is lactose or milk sugar. Here the ring of the glucose is able to open even though a glycosidic bond is present, so an aldehyde group is provided. In the Fehling's test, the following reactions take place. The copper ions are reduced from the oxidation state of +2 down to +1, which causes copper 1 oxide to form and precipitate out. As an example, an aldehyde is used, which is oxidized to a carbonic acid in the reaction. This is deprotonated due to the basic conditions. This was the Fehling's test for reducing sugars and aldehydes. I hope you enjoyed. Please rate and comment.